So this part is about evolution trend about conversational system. So first dimension is definitely better performance, because we mentioned in understanding part, we need to predict the intent and also fill the slot. And also we mentioned the model sometimes can consider the intent information and slot information together and get a better performance. Definitely want to move forward, want to have better understanding performance. But sometimes if you interact with your current system, you will find there's still a big gap between the current one and also the environment's drivers. Because if you want to have very good performance, you need to consider the spoken scenario, which we call spoken language understanding. In the natural language understanding part, when the user uses the speech to interact with the system, it say, please buy me Thai food, okay? So you will see this sentence in the written text. So previously we introduced some natural language processing tasks and models to tackle this problem. Based on this sentence, we need to recognize the semantic behind this sentence. However, if we only consider the natural language part, it means we just treat the scenario as the input comes from the text side, just like you type your sentence in. So there's no any mistake in your natural language. However, in the real scenario, sometimes the original signal is speech. So if you only look at the sentence, lift or light to Morocco, it's very difficult to correctly understand this sentence, right? The reason is there are so many misrecognition in this sentence. The correct one is lift or fly tomorrow. But if you listen to these two sentences, you will find the acoustic signal are very similar to each other, because the speech recognition may misrecognize the speech into the incorrect sentence. So if you only look at the sentence side, in the written sentence, without considering the original sound, you sometimes cannot get the correct meaning about this sentence. That's why we want to consider the spoken language understanding scenario. That means we need to consider the speech processing part and try to fill the gap between the speech and also the natural language processing, because usually speech processing and natural language processing are done differently, independently, but there's a gap between each other. Speech recognition tries to recognize speech into a perfect task, but natural language processing just assumes the input are perfect without any errors. But in the real scenario, there's an error from the speech side, and the natural language processing should consider this speech recognition error. So that's why if we want to get a very good performance, we need to consider the speech scenario. So our group trying to have some spoken language understanding information. For example, this is, although there are a very cute cartoon in the right-hand side, but it's a very famous model in the natural language processing. It's called Elmo. Originally, Elmo just look at a lot of book, but they cannot listen to the words. They can only read these words. And we want to allow the Elmo to listen to the sound. For example, in the original act, in the first sentence is the correct sentence. Show me the fares from Dallas to Boston. And the second one is the recognized by the machine. Show me a fares from Dallas to Boston. Although there are two different words, but if you listen to their sound, they are very similar to each other. So we can see these two words are acoustic confused to each other. So we hope we will have very similar information for these two words. Just like we don't need to worry about current scenario has some misrecognition, we directly utilize this spoken Elmo, then they will automatically have a good understanding for the information similar to the original correct sentence. And sometimes if you cannot get the correct sentence, you cannot do the previous approach. And the alternate approach is you just utilize the current speech recognition system and allow the system to generate several candidates for you. So they will generate several candidates, and you will know that based on the mapping, you will know these two words also have a critical confusion, flights and lights, and you will try to make their two words sound too similar to each other. So they will have very similar vector to each other, and you will also have a good performance after utilize this scenario. So after this dimension, better performance, another dimension is called scalability. Because the current scenario, like a lot of chatbots, only focus on single domain. Just like this is a movie bot, they can only handle the movie scenario. This is a restaurant bot, they can only handle restaurant scenario. But you want to extend the scalability of the system. For example, you may have the traveling bot. They can handle the hotel booking and also airline booking because they are relevant to each other. So you don't need to interact with two different bots. You just want to interact with a single bot and try to finish multiple tasks. And definitely, just like Iron Man's drivers, which is the open domain system, like there's no any constraint about the domain. Any domain, any topic, they can handle as well. However, if you remember the previous domain definition, domain is defined as the database we need to search for. So the first constraint is about the database we have. If you consider the information you have, like a database you have, sometimes enterprise say, although they have a lot of table, like a lot of database, but there are only 20% of the enterprise data are stored in this structured scenario. There are more data, like 80% of enterprise data is stored in the unstructured way. For example, some image, some Word files, or some emails, they are just scattered to different locations. And if we do not store them in a structured framework, it's a little bit difficult to interact with, just following the previous framework. Because the previous framework, we need to convert into a query to search the database. But if you do not have the database, there's no way to search for. But how to access this unstructured data? There's another solution. You just allow this machine to read this unstructured text. For example, you have a lot of files, right? You just ask this machine to, you read all of this file, just like a teacher. And I'm the user, I can ask a question to this teacher, just like a student. And this question can be asked in a conversational manner, just like a conversational system. For example, after the machine reads a section about the description about this topic dog, the student can ask a lot of questions about this character. For example, what's the origin of this dog, and so on. However, you need to consider the previous question or previous answer in order to answer the current question correctly. For example, if you look at the third question in this slide, was he the star? You need to understand he means this dog. So you can answer this question correctly. So it's not very trivial because you need to understand the original passage and also understand the previous history about the answer and also questions in order to get the answer to the current question. But this is a way to allow the machine to access the unstructured data, not only the structured data in the database. This task called conversational QA. So you can have a machine which focuses on unstructured data. You will have another machine focused on structured data, access the database, and they can collaborate to each other and try to help you to answer different type of questions. However, if we back to the original framework in the dialog system, this is the database, right? So the database in the right-hand side have the domain information. If you have a domain, just means you have different database to search for. But if we don't want to have the domain constraint like the open domain scenario, that means you don't want to query the database. Okay? You don't want to connect to the database. If you don't need to have the query information, that means you can directly treat the whole system as a very big model, like a neural network. You just, based on the input, we learn how to get the output. Don't need to separate into several components. In the previous framework, why we need to separate into different components? Because we need to have the query to search the database. But currently, if you don't need to search the database, you can directly learn the output based on input side. That is called neural response generation. And a lot of tasks focusing on social chatting just use this approach to model the how to generate the response according to the certain source. For example, you can collect the source, which is a conversation history, as the encoder, and the target is trying to generate the corresponding response. For example, how are you as the source? I'm fine, thank you, and you is the target. You just need to have this pair of data and you can train your model. Try to generate the corresponding response based on your input. So in this side, this goal is trying to design which target sentence has the highest probability given the source sentence. Okay, based on this question. It's very simple. Based on the source sentence, we need to find the target sentence which has the highest probability. In this scenario, you just need to collect a lot of conversation and use the previous sentence and the next sentence as the input and output, and you can train your model. You don't need to get any annotation. You don't need to have the action information. You don't need to have the intent information. So previously, research come up with this idea. They just collect a lot of movie script and they have a lot of conversation, right? And then just use the previous sentence and the next sentence as the input and output as the training data and try to train a movie bot. So in the beginning, you just give them a first sentence, they will generate the next one, and then you use the next sentence as the input, they will generate the third sentence, and so on. And afterwards, they will finish the whole movie. So this is the example movie generated by machine based on the previous model. However, I just make a short clip of this movie, and the subtitle is automatically recognized by speech. So there's some misrecognition. So you need to listen it carefully. Let's see this clip.
Go to the skull. I don't know.
Ooh. Huh. What do you mean?
Well, I don't know anything about any of this, so.
Then what?
There's no answer.
We're going to see the money.
All right.
Okay, what do you think about this short clip? every time I ask this question and I just see the confused face from the audience. Because if you dip into their conversation, it seems fluent, but you don't know what information they want to convey to. The reason is there's a very big issue which is called blindness problem. Because machine is too smart, they just pick a very general response to the different type of sentence. For example, you will find that they will say, I don't know, there's no answer. This type of general response appear very frequently because machine automatically find if we can use this general response, we don't need to worry about what the input is. We just say, I don't know. Of course, this sentence is good enough. And if you directly utilize this neural response generation approach, you will have like 30% of response are meaningless because they are very general. Just like if you enter a party and a lot of foreigners are talking to each other and you are very tired and you don't want to listen it carefully. But if somebody cute and somebody say something to you and you cannot understand correctly, you can just say, oh, interesting, and it seems okay, it seems fluent, not very weird, but everyone know that, oh, there's no specific meaning, not specific topic. So there's very important issue the machine will find because they just directly find the target sentence which has the highest probability no matter which input is. Just like this example. And one solution to this scenario is called MMI, Maximum Mutual Information. The idea is very simple. Because the previous approach is based on the source sentence, you want to maximize the target. However, you will directly pick the target sentence which has highest probability. But you want to also maximize, given the target, you want to know the original source. Therefore, you cannot pick the general sentence because if you pick the general sentence, it's very difficult to know the original source. So after adding this information to your model, you can see that the answer will change. Previously, the answer only contained of course, but currently the content of course you can because the original question had, can I have one? And they also say they are delicious because the previous question will have something like make your mouth water. So they were more topically related to each other. So they are better, not only specific to not only general to very meaningless topic. Okay. So there are another scenario we want to move forward to the open domain conversation. However, there are also another dimension we want to talk about, which is called complexity. Usually, you will see a lot of bots, a lot of systems focus on the knowledge-based side because a lot of people want to access the knowledge first because knowledge is more objective and do not have a lot of subjective issues. So it's easy to evaluate. But sometimes, if you want to have just like a Jarvis can understand the common sense and probably empathetic system, just like Baymax. So it's very difficult. How to handle the common sense scenario? What is common sense? Let's see the example. If I look at this user's behavior for using the app, first of all, they want to use the first app to find a restaurant using Yelp. And the second one, they check the restaurant location used Google Map. And they contact to the person they want to meet, use another app, use Messenger. Okay, so currently this user uses 3 different apps belonging to different domains. However, if we look at the ultimate goal of this user wants to schedule lunch with Vivian, so that they need to find a restaurant and check location and contact Vivian. So if you are the boss and you will have a human assistant, you can directly tell your human assistant, say, I will need to schedule lunch with Vivian. So this assistant should be able to decompose your sentence into 3 different domains. They need to try to find a restaurant for you and try to check the location and also send information to the person you need to meet, because they can understand the common sense. So they can understand the information behind this original request. So user can only interact via high-level description, and the system try to learn how to plan this dialogue in order to achieve this common sense. But this is very difficult, and the current system, they cannot handle this complicated scenario, but the human can. That's why we will see a large gap between the machine and also human, because you need to know a lunch means you need to have something to eat, and restaurant provide the eating information, so you need to go to a restaurant, you need to have the connection between each other. So it's very trivial to the human, but not very trivial to the machine. And also, empathy is a very vague concept, specifically for machine. If you want to embed an empathy module in the system, first of all, what empathy is, we need to recognize the emotion for the user. We can base on the text or a speech or the facial information like a vision to recognize the emotion and try to generate the emotion-aware information. For example, this is a very interesting interface produced by Hong Kong Technology University. This is the bot called Empathetic Supergirl, and they will have a conversation with the user and try to predict your personality afterwards. So they need to know your emotion and try to continue the topic you talk about. And afterwards, they will have the prediction about your personality. So there's a very interesting scenario to have empathy, but definitely you will know that why this is very difficult, because different people will have different empathy concept, and they will have different reflection to different emotions. Okay, so we are going to the class activity.
Okay, it's time for pop quiz. Today we have 5 questions, right?
Yeah.
And the first question is, it's a single choice. Choose the wrong statement about language understanding. You can leave your answers in the message for us to check. Let's see if anyone's answering. Okay, I got 2 C's. Any more? Are you participating today? Are you guys still there? Come on, more answers. So the answer is
C.
Sentence level classification can be used for slot filling. That's not right.
That's not right, because in the slot filling, we need to extract the information from the sentence. So the better way is to do the sentence tagging. Like we need to tag each word as a label so that we can extract the word information based on the slot filling. So sentence level classification is not proper for this task.
And question number 2, why is reinforcement learning more suitable for deciding the system action policy? Okay, any answers? Are you ready? The answer
is C as well. Dialogue are interactive behaviors, so that it is difficult to decide the correct label for each input sentence. As we mentioned before, it's very difficult to have the supervised learning because in supervised learning we need to have input and output. But for this question, there's no correct action. You can have different strategy to make the final task successful. So it's very difficult to design the correct label. So reinforcement learning is better.
Okay, and question number 3, choose the wrong statement about dialogue state tracking. And the answer is?
Answer is D.
D.
Training a dialogue state tracker requires reinforcement learning. Now we can use supervised learning. Just we collect the conversation and we will have the history of the conversation and we will have the corresponding dialogue state as the label, and we can do supervised learning as well.
Okay, question number 4. Which statement about NLG is correct? Any answers? Okay, Vivian?
Answer is A. As I mentioned, most current products mainly use template-based method for NLG because it's easy to control and they don't want to go and have some legal issue, because sometimes machine learning based approach will generate some word, maybe dirty word or not proper word.
Okay. And question number 5, choose the wrong statement about dialogue evolution trends.
This one is a little bit difficult.
Did you just choose the most difficult questions for everyone? Okay, and the answer is?
The answer is D. A blindness problem will happen not because these general responses are most frequent in the data, because they have the high risk probability, because it's very easy to have a higher probability to the different input. Not this general response appear more frequent than others, just like they have a higher probability. So it's a very difficult pop quiz for this today's.
Okay, thank you very much. So before we continue with our second half part of the class, let's take a short 5-minute break. Okay, see you guys in 5 minutes.